All right. So when we were before, I told you that when you wanted to use a function in main, you had to put the function above main. Use it. In general, people don't do that. They use what's called the declaration definition to basically very cleanly give you like a table of contents almost. And then if you want to go look for the function, you can look for it later in the file. So the main is usually your first function that you'll encounter, and everything else comes below. So really quick, it'll look something like this. What you have to do is you start. You have your normal file start, and then right below that, you can basically give it exactly what's called the definition. The declaration of the function, and then you end it with a semicolon. So you can specify the name of your parameter here if you want. You also don't have to. I'm going to show where you don't have to. So I can now make the function int even below. And just to show you, I get CLine puts in this nice little arrow which says, hey, you can jump from one to the other. So it's just kind of showing me that these are equivalent. All right, this is just kind of like to be a little bit easier. So generally, you should do this. Highly recommended to declare your functions above and then define them below your main. Just as a programming practice. But these are the same. This is not like all this does is just explain when it's reading the file that there's going to be a function called this later. And then this is the actual function. So it says keep looking, basically. It's all fine. All right, so that really quick is declaring functions. Again, it's just kind of a little bit of side note. We're going to do a couple of backtracking through some of the stuff we already covered, just to kind of do a little bit of review. And then we are going to do arrays, and that will be it for today. So, really quick, we're going to do some Boolean logic to start out, if else kind of stuff. So you don't need any functions. Yeah, you don't need any functions. We'll get to that in a bit. So, basically what I want to do is I'm going to give you a couple numbers. And I want you to give me the biggest number back, okay? Okay, so basically I'm going to give you three numbers, and you don't have to write a function. I guess you can if you want, but so I'm going to give you three numbers. I don't want you to tell me which number. I want you to write some code that figures out which is the biggest of the three numbers, okay? And then I'll print it out, okay? We're all ready, of course. You don't have much. You guys can take some. So then we need the question again. I'm going to give you three numbers. I may change them up but I want you to compare them, find the biggest of the three, and then print that out. And I'll go over my solution. So hit hit button on your red. Yeah. So that. Now let's try over. You're currently returning. I would create some variable name since they returning. Sorry, I will give you. I'd recommend something like this for people. Create a max, use some code, print out max. Anyone almost done? Close? Is it done? Good to go? Try changing up your values, just as a recommendation. Here's one set of values. In my example, B is the greatest. Try making A the biggest and C the greatest. Double check that your code works. Maybe make A 15 in the next one, and then make C 25 or something. Double check it works. Then I'll go over my solution as well. Good. So you already know this. If A is greater than B, you say else if B is greater than C. Whatever the C is the greatest, it's 3. And this is both of those. Yes, got it?
Yeah, I feel like I chose the really crappy.
That's why I'll cover my answer as well. I'm gonna get with these. I'm gonna give you my answer. Now, there's no guarantee mine's even the best of all of like any of these. But I'm gonna show you basically how I'm gonna do it. And some of them may go, and I promise you that's what I did when I saw some of these answers. What words? Got it? You got it? Did we try 3 different numbers? Try with A greatest, then with B greatest, then with C greatest. I will say this, if you guys ever are going to write code for assignments and programming, you can always check your work before turning it in. That's the beauty of code. Alright, yeah, it works for all 3? Yeah. Perfect. Okay. I promise you, you'll see, it'll look complicated. Your solution will definitely look complicated first. Trust me, I didn't come up with this. I'm about to show you. I didn't. This is something I read in the textbook and I was like, man. You got it? Thinking about it? Okay. Yeah. Good? Working? Yeah, just put space. Alright. Yeah. Oh. I see what I have it here. Just do this fast, yeah. That's it. Okay. Already? Almost? Close? Got it? We're using 4. A is greater. So currently, yeah. That's close. Almost there. You got it now, yeah. As soon as you have your answer, I'm going to ask you, when it's ready, tally how many times you make a comparison. If you use an and statement, tally it as 2. If and is 2 comparisons, okay? You ready? You guys ready? So, how many comparisons do you guys have? It's okay, no worries. 5 comparisons? 6. If A is less than B is a comparison. If A is greater than B and A is greater than C, that's 2 comparisons. You compare A to B and A to C.
If it's and, then they're considered 2.
Yeah, you said if A is greater than B and A is greater than C, for example,
Then that's 2.
that's 2 comparisons.
Oh.
Yeah, you compared A to B and then A to C.
Okay, 4.
4? Okay. So I'm going to tell you you can do it in 2 comparisons. Okay. And this, it feels really sad. Ready? So I'm going to say my max is A before I start. Okay? So, my first start basically says, there's basically repetitive comparisons, and here's what I can say this is that the reason you can do it in 2 is because if you use any more than 3 comparisons, you have to compare something twice. So you only want, once you have a biggest value, you should only be checking contiguous values one more time. Once you assign it. So I'm going to cheat and say my max is A, and this will still always take 2 comparisons, but I can say two comparisons. So, really quick to run through exactly how this works. I'm going to say A is my max. I'm going to make the assumption A is the actual maximum of my values to start. We'll say A is maybe 20 in this example. So the max is 20. Is 13 greater than 20? Nope. Is 9 greater than 20? Nope. Neither of these assignments happen. I print out A is my max. So let's take our example from here. We have B as our max. I say the max is 10. Then I say, is 13 greater than 10? It is. Assign B as the max. Then I look at 9. Is 9 greater than 13? It is not. So B comes out as my max. Okay? For our final assumption, let's say C is our biggest number. Let's make it 50. We'll say the max is A, it's 10. Then we say, is 13 greater than 10? It is. So max is 13 now. Is 50 greater than 13? It is. So our max is C. That's all it's print out. So in exactly 2 comparisons, I can figure out the maximum number. If you're interested in a little bit of background in computer science, to find the maximum of every single value, it takes n-1 comparisons, if you're interested in that number. There were 3 values here, and required therefore n-1, or 3 minus 1, or 2 comparisons to do it. Okay? If you are interested. The important thing is to not use else if here, just to be careful. Because that means if C was the max of the 3 values and you had an else if and B was greater than A, then this would never execute. You never find out C. You never check that condition. But exactly 2 comparisons and I can do it. So I know it feels really sad when you look at it at first. You're just like, yes.
Can you explain again why the else if statement would have
So in if and else if, as soon as I run into so I'm going to call it an if, else, if, else block. So any set of statements out of ifs, else ifs, and elses. For example, this would be an if and then an else if. The moment I run into an if statement that has an else if and it evaluates to true, I will skip all other else ifs and elses until I run to the next actual line of code. Because all ifs, else ifs, and elses come as basically a block. So I can demonstrate just to show you. So in the way this example would fail is that my if statement would execute as true and it would skip my else if. So really quick, my max is 40. We can agree on that. And we'll run it. And you see we're not going to get 40. You get 13, which is B. So it evaluated here and said, is 13 greater than 10? It was. It did the assignment. It skips the else if. So it didn't make us check to see if C actually was greater. So that's how that didn't work out. Okay? So now we're going to do 2 different questions. This next one's going to be, I'm going to give you 2 values. I'm going to give you two values. It doesn't really matter what numbers you pick. I'm going to tell you swap them. Okay? So at the moment, value 1, it stores 100. Value 2 stores 50. I want value 1 to store 50 and value 2 to store 100. Okay? Remember, any way you do this is fine. Okay? The point is just to be doing these kind of computer science problems. And we're going to learn something along the way.
Nicholas,
Yes.
are we allowed to just make it better?
Yeah, you can do whatever you want.
Okay.
Yeah. Again, this is open for you to try, and I will show you some answers. And then we'll think about it, okay?
Delete the previous one.
Yeah, you can delete the previous one. Perfect one.
So we're just switching the integer values?
Yeah, value 1. Oh, sorry, I'll give you a little print statement as well. Yeah, so we have value 1 and value 2. Currently, value 1 stores 100, value 2 stores 50. I want value 1 to store 50 and value 2 to store 100. Okay? And I will give you something to let's see about it. So. Anyone got it? Ready to go? Okay. Perfect. Remember, this is just for correctness, guys. You can do whatever you want in the middle. This is just for correctness. I'll show you an answer too, and I'll show you something fun as well. Yes.
Interesting class.
Just stop the print.
Really?
Yeah, it peeled. Back right side, back left side. It peeled. Just stop the print. Just don't print it.
What is it?
What?
What is it?
It's printing a business card holder. Damn, that sucks. Okay, I guess we had to just do it. I was waiting for it. The file comes standard. Do you have matter control installed?
Yeah.
Okay.
I'll go ahead and
Next one.
Is
Is this the brand thing?
It's pretty much
We wrapped it.
Yeah, it's pretty much the same.
Wait, how is this a business?
Well, it was, but you see this entire side right here, it started lifting because the
Yeah, and stick to the
plastic didn't glue on properly. So honestly, I don't think the glue is the issue. I honestly think it's just the plastic. The plastic didn't adhere. For some reason, it didn't adhere to the wrap.
Yeah, was it? Oh no! It didn't stick to the bed. The problem was it didn't stick to the bed.
Oh, the entire thing fell. Oh,
Yeah, the entire thing was not connected to the bed. It wasn't even just the wraps.
dude, just douse the entire glass pane with
You just need
Elmer's glue.
You just need corners where it does actual corners. That's where the problem happened.
So whoever I guess finishes this code first gets this one.
It's this.
Happy birthday! Now let's finish it off.
Do you want the wrap or do you want what almost was a business card holder?
Either.
3 hours later, it won't be business.
3 hours later, it will be a business card if you want to stay around. Maybe you can take the bag. This is the bag on the bottom.
That one's cool.
I guess they're bookmarks. That's what they are. They're bookmarks now, guys. Anyone who actually reads instead of writes code all the time like me needs a bookmark. So, but I promise you, once you finish, any answer's correct. Just remember, success is the only measure of correctness right now. I promise you. There's no reason to measure you on maximum efficiency in
So this
intro
one
class.
is value 1 to display 50 and value 2 to display 100.
Yeah, I'm giving you. You want to put some code in here that basically takes whatever is in value 1 and puts it in value 2, and takes whatever is in value 2 and puts it in value 1. That's swap. Then I'll give you the smart aleck answer, the normal answer, and then the cool answer.
What class is that for?
Oh, well, I teach 3D printing. That was for just because Albert wanted to see if the plastic worked.
Oh.
So, okay. Yeah, we'll give you many. The next person who's ready gets that more bookmarky looking bookmark.
I think a really big answer.
That's fine. Yes, the correctness is the only measure of success. Oh no, you need. Okay, no. You needed to change the values though. What if I change them from 150? And
Yeah, I got it.
you got it. Perfect. We should print more things. Just keep 3D printing things for people. I'd have to start a print before class.
What program do you use?
It uses. I just use a slicing software for the printer
CAD?
itself.
Or Blender.
Do not use Blender for 3D printing things. Please no.
Can you use CAD?
Yeah, you can. Yeah, you export to STLs, and then you can use the slicing software map.
I just use Blender to mod games, basically.
Yeah, that's fine. It's 3D printing things is hard
Oh.
because the way things 3D print well is by giving them a 3-dimensional coordinates, like a point in 3-dimensional space, And then STL files are like stereo triangular, some triangulation or whatever it's called, where they use three-dimensional points in
Can
space.
you export
Define
that from
points.
Blender to?
You can, yeah, you can try and export from Blender to STLs, but like it doesn't work as well. Because again, Blender allows you to do very nice rounded edges, which don't come out well in three-dimensional space unless you have a really, really specific file, which kind of blows. So, which makes it a big file. So. But remember, anything goes, guys. Anything goes. Yes, you got it?
Yeah, but I feel like it's missing something.
Don't just swap it to print. You want to actually write some code. If I give you two different.
Do you have any of your own software like in the topics like on the internet?
Wait, sorry, what?
Do you have any of your own software in the topics like on the internet?
Yeah, I've got some stuff.
Like what?
I've made a couple games and apps and things.
Oh.
I have like AI that perfectly plays tic-tac-toe. So you can only win or draw versus it.
Oh, I've seen that before.
Kind of frustrating to play against, honestly. Like you play.
Did you use a neural network?
No.
Oh.
No, it just takes advantage of a little bit of some heuristics and a little bit of prediction. So when I first designed it, it tried to compute every single possible tic-tac-toe move, which didn't really work out so well, as your computer only has so much memory. So I used a little bit of a heuristic to cheat on the first couple moves, and it works. So it's kind of interesting. I did set up a test case to test every single first starting moves in tic-tac-toe, and it always wins your
Do you have
ties.
your own GitHub account?
Yes, I do. I've got a couple apps. No, I deleted one. I have one app now. I don't have the tic-tac-toe app on there anymore. But
Which language do you use to code the tic-tac-toe?
Java, like XML. I was going to use C++, but it's easier just to write, because it just exports C++ code to Java. So, like if you try to write C++ code in Android Studio, just kind of like, what's the point then? I'll just write it in Java.
I made a tic-tac-toe with the Python.
The Python?
Probably not as good as yours though.
Oh, I just made one for a Python class.
Oh, you did?
Yeah, I teach the Python, well, I was for a little bit subbing for it. We made tic-tac-toe.
Oh.
I can show you. It's on the command line though. It doesn't have anything fun. My tic-tac-toe app you can actually download on your phone and play. That was a lot more fun. A lot more work though. We close? Figuring it out? Think about it. Swapping two values. I will give you a hint, a third variable that helps a lot. People close, ready, almost. Good, working. Oh, perfect. You ready for the answer? Or a couple answers, I should say. And this is a little bit of a fun demonstration as well. Let's get it. So how many times do most people do these? How many extra variables would you create? One.
Can you do it without any?
Maybe. So really quick, let's bring up two people. And I'm going to demonstrate a little bit of what your swap is doing. I promise I won't make fun of you. So just be, it's really just a demonstration, I promise. Just to see what your code does. And I'll write what most people did as well, really quick. Whoops. I'm crazy, I'm clicking the wrong buttons. Something like this. You used a temp, created it, stored it, the location, and then you just move both of them over. Something like that, yeah? Okay. Two people. One.
Maybe knows this. Knows this. Wait, who's the last one?
I promise, it's not that bad. Okay, we're going to really quickly run through the swap. And sit over these two chairs to start. Okay, so really quick, we've got our variables right here. We're going to swap them. Here's your code's doing. This is one of my favorite little like diagram or things because the cheat way to do it, you can do without a temp. I'll tell you right now. You can even do it in one line of code as well, which you can't demonstrate like this. So the amusing part is to think about how this would work in your head if you had people. But really quick, you create a third value. You call it temp. Let's move one person over from value 1. I can easily. We'll put in our temp. Yeah, that's fine. Yeah. We move in, we put our temp over here. Now we have it over. We can assign value 1, the value from value 2. So we can just move right over. And then once the space is vacant again, we can move our value 2 back in from what we got from temp. And that's how we can swap. Now I will give you really quick the Smart Alec version. There's this amazing thing called it's in the standard library called swap. You pass it 2 values and it will swap it for you. Just to prove I'm not just crazy, I'll make this 125 and 2. Standard swap. Library functions. Then really quick, here's a couple different ways you can do this. So there are two cheaty ways to do this. There's one which is the cool way with math, and then there's another cool way using computer science, which is even better. So, really quick, how to swap without a temp. Let me pull up. Okay. So, we got these, right? We're going to say, let's do value 1 equals value 1. We'll just do that one. Yeah, equals value 1 plus value 2. Okay. Then value 2 equals value 1 minus value 2. And then finally, value 1 equals value 1 minus value 2. Okay, this is straight without a temp, 3 lines of code. And my mouse goes. 3 lines of these. Swapping without a temp. So, really quick, this is part of what you can kind of do with a little bit of math. If you want to think about this with people in chairs, it would look a little weird. You'd have to duplicate yourself a little bit to get the idea. But The idea is we can sum the values. So right now, I'll just run through this. We have 125 and 2. We say value 1 is the sum of both values. So value 1 is now 127. So the important thing is we don't have the number 125, but we do have a way to get back to it. We know if we subtract value 2 from value 1, we'll get 125 again. Okay, so we haven't lost 125 yet. And that's kind of the trick to this algorithm. So now that we do that, we can say value 2 is value 1 minus value 2, this is now 127 minus 2. So now we have 127, and we're going to store 125, or 1, okay? So we're storing 127 minus 2 in here, which is 125. So now we don't have the 2, but we have 127 and 125. And now we can subtract one from the other and do 127 minus 125 and get the 2. So despite never actually taking advantage of a temp, we did use basically a trail of numbers without ever losing that exact value. You can do this with multiplication and division as well. But yeah, so I will say though, swapping without a temp has a little bit of a chance of you running out. So numbers can only be stored that are so big. So if you use like multiplication, you try to store like 1 billion times 1 billion, you'll run out of space and you'll fail. So really quick, I'm going to show you the super sneaky way, which is basically people in computer science said, this is nice with math and all, but we're better than that. So let me get this one up here.
Can you also get it with modulus?
Modulus? I don't think so. Because it would bind, because when you do your output from a modulus, binds your output between 0 and whatever the right-hand operand is on modulus. So if it was 127 modulus 2, it'll return a number between that's either 0 or 1. Okay. So really quick, I'm going to show off the super cheat mode temp swap. I'm actually not 100% sure if it'll let me do this. So come back. Let's see if it'll let me. Kind of hoping. Let's see. X bitwise or value 1 bitwise or exclusive or y value 2 exclusive or value 1 and then value 1 exclusive or 2. Value 1 exclusive or value 2, yes, perfect. This is going to look a little bit crazy, I promise. You'll go, what the heck?
What's that operation with the arrow?
Yeah, I will explain it. Let's do 15 and 37. Okay. Oh, you can go back to sheet, by the way. Bam! Ooh, yeah, first try. Okay, so this is computer science's super cheat way, which is using an operator called the exclusive OR. So this is the exclusive OR enhanced assignment operator, or XOR, if you want to say one word, but people don't say that. It is XOR, if you want to look it up on Google and what it does. Exclusive OR says things have to be mutually different for them to occur. So basically, I take advantage of that same thing from before. So the one from before that used the pluses and minuses did that with actual numerical values. This does this with memory addresses. Okay. So this is taking way more advantage of computing. However, in the real world, this is actually a slower operation than using your temp. Just so you guys know that making a temp and swapping it around is faster than this one that does it with memory addresses, an exclusive one. Just FYI, okay? Ever so slightly. But so here's a couple examples. There was swapping it with your guys' way, swapping without a temp, swapping it without a temp computer science style, and then using the library function swap, which does something like this almost with a temp though.
Wait, how does that work?
So exclusive OR requires that says that it'll basically take the bitwise representation of it, the memory address, and then compares against the other, and it works. Then once you see that they're different, it does an assignment. So it assigns memory addresses basically over the top of each other using a binary addition. So instead of seeing the one from before that added the numbers and then subtracted them, it was like, oh, it's snazzy. It does this with memory address. It takes its actual memory address and uses it. So there's a point in this where value 1 points to absolute garbage, for example. Like right here. You know how that when we did the 125 and 2, one of them was 127 and absolutely garbage? It's doing that same thing right here, okay?
Oh.
So this is just a fun one. I promise you, most people don't use that. They'll use the temp swap because it's optimized, highly optimized registry swap. That's it's actually built into processors now.
Wait, so what exactly so for example, like, can you just explain what that first line does? Like value 1, whatever that value is.
So this is an enhanced assignment. So remember that's value 1 equals value 1 exclusive or value 2. Okay. So remember how if we have an operator and an equal sign, it kind of cheats and combines them into 2?
Yeah.
So that's what this is. This value 1 equals value 1 exclusive or value 2. And this is some logic basically. So it's evaluating the bit representation of each memory address. Which remember that set of numbers at 0x something or other in binary, and then it can compute it that way. So it's a little bit snazzy. It looks really weird, I promise. It's something that's way beyond the scope of this class, but that's an example of swapping. If you want, you can look it up. If you want to Google it, I guess, if you guys are interested. It's spelled XOR swap algorithm, or the XOR swap, for people that really like to say the whole thing. Exclusive OR swap, XOR swap. Again, in Google for another time. Really quick, we're going to jump back and we're going to do a couple of functions now with a little bit of the rest of our time. These aren't going to, instead of just writing our code in main, we're just going to basically put our code in a function. Oops. So remember that I want a declaration above the function and then your definition below. Okay? Declare it above, define it below. So let's do. I'll give you a number. I want you to print out the number. So I'm going to give you a number for a function. You can call this nearby, the function nearby, and we're going to pass in a single integer value. Okay? The return type will be void. Okay? Void return type, we're going to call it the function name nearby. It's going to take a singular integer argument. You ready? You got that part so far?
Wait, I wasn't sure what to do.
We want to. So remember how I did the thing with the semicolon above it? What I called the function name? I covered it very quickly. Sorry, fast, real quick. No? Okay. So basically we can declare a function and then define it later so that we can type below. I said I wanted a void return type. I wanted the function to be called nearby. And then I want a single integer argument.
That was before you, right?
Yeah, you can put it above it. So you know how you had to write functions before above your main to use them in main?
Yeah.
This is how to do it right in below. This is the better programming practice. But I'm supposed to teach the other way first, just in case. Also, so you don't get random errors.
Okay.
Just so you know what happens. So, I should mention, when I define them, I just use int. You can use int a. This is also fine. Okay? Just for the record. Okay? I just use int because that's all it requires to know the type. Again, this is how the compiler checks when it's looking for functions. You know, when you try to call like this with a double and it complains, this is how it does it. It says, oh, you're passing the buffer. So, really quick, I want the function down here below. Nearby. Whoop. Okay, what I want the closest two integer values to this number. The one above it, one below it. Okay? Just a simple cout for this. Just got it?
Do you have to like define int a before?
Oh, I want you to call it in the main. I'm gonna let you write that code as well. I said in your function, I want you to just print it out. Two things at the console. Whatever. So if I gave you 15, I want you to print out 13 and then, if I give you 15, I want you to print out 14 and 16.
Oh, so like the two numbers.
There's two numbers right next to it. The two integer values next to it. Okay, I'm gonna leave the actual way to call the function blank as well.
We define the numbers in a function nearby.
Yeah, I want you to call it main. You can pass in any number really. I'm not that picky. I just want to see you call it. Okay? Call the function in main. Just write the code, do it here. Just use cout nearby. Just keep it simple. We'll do one more of these probably, and then I will sneakily introduce the next one. on the Zora story a little bit more. I was kind of interested. Time-based side channel. Anyone got it so far? Ready to go? Nearby?
Or do we set initialize a to the number in the function?
Yeah. In main, give it some number to pass in.
Oh, in main?
Yeah, in main you want to call this function. So you should have one line of code in main that calls the function nearby. You can give it any number. I'm not picky.
Where does that go? Does that go inside?
In main, yeah.
Oh.
Yeah, it's so quiet. I want to offload the stupid specs.
Stupid specs?
Yeah, for that. Or is it online?
Oh no, the matter control just sets it up just fine. You just have to give it when you connect the printer, it does it for you. You don't have to change it.
I already connected to it, but then I never got the
What's it print? Is it printing at 210 medium settings PLA?
No, it is. No, but I never
good.
got the or
You should be good. Did you download a matter control?
Yeah.
And yeah, it should come with those settings once you connect it.
I don't know. It's like it was jank. I'm screwing everything out there today. Why is this applying anything?
We're doing like basically practice problems.
Is it working?
No, there's no period.
There
Period.
are no.
Get out of here. Well, compiling problems are things I can answer. I won't answer exactly how to do the problem, but if you can't run your code for X or Y reason, you can ask me. Or if you would like wondering why something is not working, I can tell you why it's not working.
I'm not sure if this is how you're supposed to do it.
Yeah, that's fine.
It's inside the main though.
Oh, no. I want you to call the function in the main. So in main, just call nearby. Just one line of code in main. It calls nearby. Like the way we want to use a function. So I want your main to look like this. You can write your code like right down here. You can follow this form, the whole thing. I just wanted you to call the function. Pass in some number, like 20. Or 2 in P for whatever reason. 20.
Where do we define where do we define it? Oh,
You write the code right here. Yeah, sorry, I try to leave it like form. You can just fill in the blanks basically. When I write some sample code, it's usually fill in the blank. Kind of. Don't fill in the blanks around here.
this, right?
You can, yeah. You don't have to. You can just use this and just write it down here.
Like I put a value of the integer a in void nearby. Then I put a pointer in a, and that's how I got.
Yeah. You can also do it in one line of code without even any pointers. And technically, it's passing by reference. You don't. Are you using pointers with a star, or just
Yeah.
passing by reference?
No, I'm passing by
Pass by
reference.
reference. Okay.
Using the I think and.
Pointers are something that's going to take a whole week.
Oh.
So,
How many more classes do we have?
like 4. That's why it's going to be a little fun.
But there's only 4 more.
I think so, right? Isn't it in August 6th or something?
Oh.
Maybe? No?
Wait, I can't. I don't remember.
I honestly don't know now. I'll go check the syllabus. I was not crazy and tired when I made that.
Also, I thought C out won't work if it's not in paint.
No, it'll work.
What's unqualified ID?
Unqualified ID.
Yeah. It's saying unqualified ID at the brackets or after void.
Oh, you have a semicolon in the nearby.
Oh,
There you go.
they don't.
Yeah, you should be good now.
Wait, also how do you do the end line thing? Is it just end?
It's another extraction. No, sorry, exertion, and then ENDL.
So a new line on another line?
Yeah. So at the very end, you have like some C outs.
Uh-huh.
Then right before the semicolon, you're gonna add another insertion, and then ENDL, which is short for end line.
And then the colon.
And then you can leave the semicolon there.
Okay, got it.
Got it? It looks good besides that. You getting close? Having trouble? If things aren't working and you aren't following this kind of formatting, like exactly what I have right here, just like filling in, I recommend doing this. Let's see what the syllabus says for me. According to this, we have until 7:31. So like 2 more weeks. Exactly 2 more weeks. Why does our last class end on a Wednesday or a Tuesday and not a Thursday?
So it is 4 more classes?
Yeah, roughly. We're gonna cover integers. I may shorten pointers then, just so we can get to like writing a program. Maybe. Because we need to get to a way to switch our next time. And, 2 classes of pointers.
Does the 4 classes include this one?
We have Thursday, then Tuesday, then Thursday, and then Tuesday. No, we're done.
Oh, and then, okay. I thought I was going to skip the last class.
We could have a party on Thursday. I'm down. Unless I'm not here on Thursday. Then you guys can come in and have a party. I just won't be here. Oh, that means I have to create a final. Ew. I'll make it hard. I'm evil. Make you guys sad. We close?
Yeah.
Got it? Or just close? Okay. you gotta print out two numbers closest, or I should say one below and one above what I pass in. You getting there? Almost?
I think I got it.
Got it?
Yeah.
Okay.
It's dizziness. Error.
Error?
There you go. Good forward. Oh, but there's supposed to be one right there. Yeah.
Very nice.
Space.
Yeah, that's fine. You close? Ready for the answer? Or do you need another couple minutes, a minute or two? Yes, no, maybe. Almost? No. You good? Almost there? Close? Not yet? 'Cause I'm gonna sneak in the answer then. You ready? Okay. So, really quick, whoops, cut off the right thing. So, I'm just gonna do a minus 1, and then a plus 1. So, this is declaration above, just declaring that we have our nearby. In our main, we're going to call it. Down here is the definition, where we say what it is. So I'm just going to print out below and above, a minus 1 and a plus 1. And we should be good to go. We'll test it. If I'm wrong, we'll want to know. Perfect. So here's above and below. And with that, we will do the last one. And then, yes.
I did that, but it has like an error.
An error? Good question. Error 1. Can we save the error check? Oh, what's, can you open your class CPP file? Oh, it says there's errors somewhere, so there's a problem. Make. Okay. Now what happens if you hit the O button? Sure. No, it does. Oh, okay. I'm not sure. I'll have to get back to you for that. Here, let me really quickly get this last one out. Okay, our last problem that'll help you is let's see.
Great.
Okay, I actually made a calculator that does like, it's called an algorithm. It's called shunting yard, but it does calculations. Anyway, let's print a multiplication table out. You don't have to use a function to do this. Let's print out up to 10 by 10. I will highly recommend nested for loops. Wink, wink, nudge, nudge.
Wait, so you mean like what do you want when we?
So multiplication table will be like 1 times 1, then 1 times 2, then 1 times 3, then 1 times
But do you
4,
want
then
the
1 times
1 times
5.
1?
What?
Do you want the 1 times 1 to be printed out?
Oh no, I just want a 10 by 10 multiplication table.
Oh.
So 1 times 1, 2 times 1, 3, 4, 5, you know, it's like 10 by 10, so you can go and find like 7 by 6.
Oh.
Do you guys see what a multiplication table looks like? I can bring one up. And this will pretty much pan into homework. Let me pull up an image so it's easy to look at. It'll look like this. Like that, except with just 10. You don't have to print out the top parts or anything, just the parts in white, up to 10. And you don't need 0. That's okay. Just the ones. 1 by 10. So that was a chunk. Okay? Okay, let's see. Can I read that error one more time? I don't understand this. It doesn't like problems. Made star. What does that mean? A static variable was not initialized. Oh, maybe leave the semicolon at the end.
5 minutes left? Edward, you have 5 minutes left.
Could you save it and build it? Man.
How far we need?
Duplicate symbol main. Oh, you have multiple mains.
Everything else is like.
Sorry. Yeah, this is gonna pan into homework, just FYI. If you want to make it fun, you could put it into a function, and I'll give you some number to print the multiplication table up to that. You don't have to space it out or anything. By the way, I should probably
Does
mention.
it take more than 3 lines?
It'll take 2 for loops, then 2 lines inside, one inside each for loop.
2 for loops and some 4 lines.
For loop, 1 line, yeah, I guess 4 lines.
Okay.
I will give you the hint that 1 line that in the innermost for loop does all the work. Okay? The code in the outer for loop is just the inner for loop and then a print line, or C out end line, I should say. I could even show you a really cool thing how to auto space it. I'll have to write that code myself. Maybe. We'll see. I may bless you with that. Yeah, so this will be homework. We'll cover arrays next time. I want to get to them today, but that's okay. Just like this. 1, 2.